Adovasio talking about the underwater research in the Gulf of Mexico, and he's got a couple of extra co-authors, myself, Jess Cook-Hale, who, because she's a Georgia Bulldog, we've managed to ship to England for a number of years now, where she's doing a tremendous amount of remote sensing research. And also Matt Newton, who's hiding out here somewhere. Hi, Matt. All right. Dr. Adovasio?
Okay. The research reported here is a near classic example of the serendipity involved in contemporary archaeology. The data in the following section was the direct consequence of a discussion between the senior author and Frank Cantelis of NOAA held in the bar at an archaeological conference in Williamsburg, Virginia. Cantelis suggested to me that NOAA was, in his words, tired of searching for sunken vessels. I suggested that perhaps a more fruitful approach for NOAA would be underwater work in the Gulf of Mexico directed toward the location of potentially early archaeological sites. Subsequent to the Williamsburg bar meeting, the senior author met with the junior author at D. Boone's restaurant in Florence, Texas, near the Galt archaeological site, where Mercyhurst Archaeological Institute was conducting a field school. The senior author then solicited the interest of Dr. Hemmings, a renowned underwater researcher, in exploring portions of the submerged Gulf of Mexico, and the rest is literally history. In order to pursue a growing interest in submerged coastal environments, in 2007, Adovasio and Hemmings submitted to NOAA a successful proposal which postulated that the now inundated environments in littoral zones such as the eastern Gulf of Mexico should contain evidence of earlier coastlines with intact beach features such as dune ridges, as well as indications of the initial anthropogenic use of such coastal environments. We also postulated that it should be possible to identify the channels and related geomorphological features of Florida's West Coast karst river systems, which intersected these submerged coastlines during the late Pleistocene. As such, rivers should have been magnets for human occupation or utilization, and by extension, early human habitation should be located in close juxtaposition to them. We suggested that the eastern Gulf of Mexico, specifically within an area paralleling the arc of the Ocala uplift zone, was an ideal location for the location, identification, and exploration of inundated coastal environments for 5 compelling reasons. First, the onshore concentration of sites in Florida older than 10,500 radiocarbon years ago cluster along the Ocala uplift zone, which contains high-quality cryptocrystalline chert outcrops and numerous perennial water sources. These notably include Page Ladson, Sloth Hole, the Butler site, and Wakulla Springs, all of which are older than 11,000 radiocarbon years in age. Several similar clusters of sites have been documented along channel and sink features in near shore settings across the eastern Gulf of Mexico or the northern Gulf of Mexico. By extrapolation, earlier sites should be located further offshore on earlier inundated portions of the landscape. Third, inundated archaeological sites in this portion of the Gulf of Mexico should be well preserved and accessible for a variety of reasons. This portion of the Gulf is considered to be sand-starved, and the rivers of Florida that discharge into this area do not carry a heavy sediment load. So any sites near or at the inundated channels or sinkholes should not be deeply buried. Fourth, the bathymetric gradient in this portion of the Gulf of Mexico is low, suggesting that during the meltwater phase of the terminal Pleistocene, comparatively quiet early water inundated the First, the flat continental shelf without destroying surface features or riverine-filled sinkholes and channels. The low bathymetric gradient in turn suggests that the potential for the site disturbance or destruction by storms or hurricanes should be at least partially mitigated. This is particularly important for the area east of the Florida Middle Grounds, which would have been shielded by barrier islands until 8,000 or 9,000 years ago and lies outside the normal Gulf gyre. Fifth, changes in the rate of sea level change may also have affected the potential for archaeological site preservation, specifically in the case of very rapid short duration rates of sea level rise, which would have had the potential to reduce or limit the erosive effects of wave action via wave action on terrestrial soils. This is particularly true during Clovis time, when sea level rose approximately 25 meters in only 250 calendar years. Our investigations in the eastern Gulf of Mexico have generated sensing data in 19 loci within 3 sub-areas within the greater study area. This field research confirmed many of our earlier hypotheses in that we have successfully located the intact buried Paleo-Suwannee River channel in 9 locations, adding 160 kilometers in length, and placing it near the southeastern edge of the Florida Middle Grounds. That is a sub-bottom profiler shot of the edge of the Paleo-Suwannee River channel. Fourth, we have located and identified hundreds of infilled stratified sinkhole-like features with obvious but as yet unmapped potential for organic and artifactual preservation, and mapped nearly 30 kilometers of intact shallow water near shore and ripples ridges just inside the last glacial maximum shoreline at a depth of over 300 feet of water. Significantly, as we predicted in our 2007 NOAA proposal, the LGM shoreline is extraordinarily well preserved, as are the observed portions of the later shorelines closer to the modern west coast of Florida. We greatly increased our diving component of the project in 2009 and ultimately examined 16 locations from 40 to 130 feet deep. Bedrock exposures of limestone and chert were taken in 6 different locations where the sand shell hash or modern biomantling could be penetrated. 3 sites adjacent to the Paleo-Suwannee River channel with superficial exposures of desilicified chert hold some of the greatest potential for future work. The infilled karst features, and this map shows you some of the infilled karst features, with multiple layers of distinct strata, are of great interest archaeologically and methodologically. Such features were recorded in each of the study sub-areas, and analogous offshore phenomena of this kind suggest that the submerged counterparts offer similarly great potential as archaeological and/or paleontological loci. During the follow-up 2009 fieldwork, an important methodological epiphany was the practical demonstration that via multiple forms of data collection, we were able to locate and identify high-interest targets that were not visible to one or another remote sensing alone. Now, using combined side scan sonar and sub-bottom profiler data, we demonstrated exactly how this works. However, it is important to note that even with the combined system, our experiment around ray hole springs demonstrates that the orientation of buried features may be even more important than the methods employed to detect them. We also overcame this factor by hitting the Paleoswani at a right angle rather than trying to follow the meander as had been previously done from the mouth. Two additional beneficial results of the fieldwork should also be noted. First, our research team had successfully navigated the steep learning curve for our specific archaeological application of remote sensing gear and shipboard logistic issues related to their operation. Second, and probably more importantly, during the course of our fieldwork, interested third parties and researchers have provided highly useful data on their experiences in and near the study area, as well as information on similar inundated environments elsewhere and other types of remote sensing equipment that will facilitate this kind of research in the future. This information specifically included locational data on an infilled sinkhole at the mouth of the Swanee River, and further field locational and descriptive data on clusters of intact tree stumps off the coast of Alabama, Virginia, North Carolina, and Key West, Florida. This information is supplemented with additional data provided by scholars from the University of South Florida, the Florida Institute of Oceanography, the Florida Geological Survey, and the Florida Bureau of Archaeological Research, underscores the enormous potential of investigations of inundated late Pleistocene landscapes and has provided a valuable impetus for further work in the northeastern Gulf of Mexico. Finally, the church samples recovered from the 2009 research operation, as well as a sample from Wayne's Sink, were subjected to preliminary X-ray fluorescence analysis. Each church sample was fractured to obtain a fresh sample surface. Each surface was then washed and subsequently subjected to a lab rat multi-element non-focused analysis which sampled for all non-organic elements. As was discovered, there is a general consistency in the composition of underwater church samples. However, as is apparent here, there is a marked difference between the Wayne Sink material and the material recovered from the submerged sites. Specifically, the underwater material appears to have been desilicified, while calcium content is markedly increased. Further future research on these samples will involve more detailed analyses, which will focus on specific modes or series of elements in an effort to generate an elemental fingerprint for possible quarry sources, both terrestrial and submerged. Significantly, the seminal research in the Gulf was dismissed without consideration in the relatively recent summary by Mike Fott and Morgan Smith. However, the entire suite of data collected in 2008 and 2009 is currently being reprocessed by Jessica Cook-Hale and Matt Newton. Early results between Rayhole Springs, the square at the south end of Area 10, now I want to hit more recent research in the Gulf. Our work 15 years ago is among a very few projects in this area because at this particular moment in time, the earliest explorations by Jim Dunbar, Michael Fott, and other crews, and the ranging research and the ongoing research being conducted today by Matt Newton, Morgan Smith and Jessica Cook-Hale, Andy Hemmings, and a variety of others. Ongoing dissertation research at the University of Florida, which I'm sorry I confused with Florida State, is being conducted along the Paleo-Suwannee River Channel by Matt Newton and crew offshore of Dixie County, seaward of the modern Suwannee River Delta. Here they work to identify archaeological sites within the near shore zone on the continental shelf, 1 to 20 miles offshore in water depths ranging from 5 to 45 feet by utilizing a broad interdisciplinary set of methods approach, including optical remote sensing, acoustic mapping of the seafloor using an SR surveyor, autonomous vehicles, diver investigations, water-linked underwater GPS, sediment coring, sedimentary analysis, and radiocarbon dating. At present, a series of marsh sediments dating between 3,500 and 7,500 years old have been documented in place. Future work by Dr. Newton will include a revisit to the Port Paradise spring originally found by Don Sirbusk. Various members of the Anthropological Research Cooperative have been active with recent offshore work at Clint's Scallop Hole and other artifact-bearing sites offshore of the St. Marks River area. The inundated quarries in and around Clint's Scallop Hole hold great potential for future research, and considerable amounts have been written about it already by Sean Joy and Morgan Smith. Primary quarrying and early middle reduction activities seem to be the best documented so far. A larger scale intermittent remote sensing and inundated site testing project has been ongoing since 2015, involving Jessica Cook-Hale and numerous ARI staff with the incredible support of GFAST. Originally focused on locating inundated middens along the Paleo-Econfina River Channel, the methodology has now been expanded using an A1 algorithm that analyzes bathymetric LiDAR and identifies site probability and site targets to the offshore channels of the Econfina, Ocilla, and Ochlockonee rivers. This particular application of spatial analysis to bathymetric LiDAR shows promising results from 2022 and have been bolstered by a new data collection in 2023. These newly detected targets include sites that yielded new deposit types, including primary and secondary lithic debitage, as well as more shell midden deposits. However, testing has also borne out the reality that not all positive LiDAR targets turned out to be archaeological, as with any other remote sensing method. Both type 1 and type 2 errors are always a possibility. Current research focused on additional target testing along with the assessment of various conditions under which the method is most likely to be successful. The 2022 study clearly demonstrated that sediment cover and likely vegetation each affected the ability to locate archaeological sites. Furthermore, we are exploring exactly what this method is detecting or is identifying, that is to say, archaeological sites themselves or sealed features that have correlates with archaeological deposits. While it may not be possible to ever distinguish these two kinds of sites, it will remain important to consider sealed conditions along with archaeological trends which apply this method to other regions. It is, however, clear that the foregoing indicates early archaeological sites which may represent the first inhabitants of Florida and the New World at large are present in the submerged landscapes of the Gulf of Mexico. Thank you for your patience.